So now I'm gonna work with the canvas. I did this thing here. I'm listening to Relentless on the background, so I'm not gonna put the volume up, but yeah. I did this thing with lists before of creating the data frame. I finished up this whole thing here. I created a bunch of lists and then I'm passing to the lists the values here. Create this list here, and then in the exception, whenever I hit something that is bytes instead of strings, it's gonna be on this exception. Then I convert it to strings, and I put if finds Python. Then I create another contract with the ABI in bytes, and I found this solution to get just the first letters for the token name and token symbol for both reserve and the token. And I think the reserve contract name is always going to be Uniswap, but yeah, it doesn't really matter because it's better to just put it there even if it's redundant. And then I did all this stuff and I got an error that the data frame wasn't working because the way that I set up the columns. So hopefully now it's gonna work. It took a long time actually to finish. I think just the calls to Web3 are really slow. I don't know why, or if there is any way to make it faster, but usually even in the other scripts it tends to be really slow. And then I searched for this one and now I have this one here, which is a dictionary with all the information. And my plan is gonna be to create this new data frame with all this information. And I think the good thing about this is that once I have this data frame, I'm not gonna need to make another one. I'm gonna have all the tokens on one CSV, and I can use these tokens probably because it's ERC20 tokens. So I imagine I'll be able to use it for all the decentralized exchanges that are on Ethereum. Of course, the reserves ones I'm gonna have to change, but at least I have the token addresses. And yeah, then I'm gonna use the information here to get the historical thing. And now I think I'm gonna work on, so yeah, once I have this thing, I'm running this with Flask. So I'm gonna pass a list to this here in a script, and it's pretty simple the way you pass. You just import the file here, the script, then you create a variable with the data frame and the information we want to pass, and then you pass through the render template, and then you put in here in this HTML, and then hopefully it's gonna work, because last time I tried this, I think that's how I did it, to pass information from Python to JavaScript. And then I can use that list that I'm gonna get to create animations with the canvas. So that's my plan. But I'm not exactly 100% sure of what kind of animations I want to make. I want to incorporate physics into it, and that's why I'm doing the course and creating the physics library. But I'm not exactly sure yet how I want it to look. I think I want something that is kind of like a real-time animation that shows the historical fluctuations of reserves and both the balance of the tokens and the reserves, and then displays that dynamically. And then ideally I would have the other script running and putting information live. But in order to do that, first I need to get better at Canvas, and then I need to figure out a way to transform from Pandas data frame into SQL, the stuff that I already have. And also, I think I'm gonna use SQL Alchemy for the Flask part. And I think yeah, it's possible to use that to have a live feed of data coming from the Python script that is making calls to Web3, and then feeding that data to SQL, and then getting the data from SQL to Python, and then running the animation and displaying on the canvas. I think that's what I'm gonna do. And then once I have a bunch of dexes, or more than one dex, then I have to think about, maybe I can do some animations that integrate dexes and shows the money flowing from multiple dexes. Kind of like a mix of the network X type of graph, but with the animation representing volume as well. That's the thing. And the reason why I'm talking about this is so I have an idea on what I need to study here and kind of how to organize this. Because I have this idea on my mind, but I'm not really sure how exactly what I want and how to put it on the thing. And then talking about it helps me clarify the process and have a better idea of what I need to work on in order to make it happen. And so I think that's probably easy to have a way to display volume with the value of the balances. That's one. I think the other one is connecting reserves. So each reserve is going to be a particle on this simulation. And then that particle, I have to represent the flow of the money. That's the thing. Because I think I'm imagining now having a bunch of nodes. Each node is a reserve, and those nodes are connected to a bigger node, which is the decentralized exchange. And then exactly like a network X, but instead of having the simple connection, having something that is like animated, where you have the flow of liquidity from these tokens on the reserves and on the DEX and on multiple DEXs. And then just see this flow. And then perform calculations, physical calculations on top of that. So what I need is, so how to create nodes, connection between them, change size of lines, connecting nodes based on the value of balance. So first I'm gonna look at the nodes, how to change the size based on the value. I think I'm gonna try to get the information right now, actually. The balance. The problem is I don't think I have the data frame with the balance yet. I didn't do that one. Maybe I can create a dummy data frame using NP. I think I can use, that's probably what I'm gonna do. And this is GitHub Copilot giving me instructions. Let's see what they come up with. I learned in NumPy, but some of this stuff I forgot about it. I know the basic methods from my mind, which is linspace, which creates a NumPy array from one point to another based on the step size. That was the one that I was thinking about using. Then I have the NumPy zeros and uh, NumPy random or something like that. Yeah, I don't think it's gonna create anything interesting. So yeah, so this goes from 0 to 100, 0 to 10 in 100 steps. And then the addition isn't cracked. It would be good if I had the vectors already. I think I know some vector manipulation, but I haven't done the whole core set. The eigenvectors part is coming up next. And I'm probably gonna have to review several times until I know by memory and I actually understand. But I know I can use. I'm thinking about using some matrix or something like that. To resemble something that I would do with a machine learning model, which would be to multiply a vector with a matrix in order to solve the linear equations of biases and weights. That might be interesting. Because there's also, it's probably something that I'm gonna do after I have this whole thing finished. Just to apply a machine learning model and do calculations on top of that. It's way far ahead. It's probably gonna be a lot harder. So I know for NumPy you do matrix manipulations with that here. On that method is to create a random vector, I think. I think I'm just gonna do something simple for now. Maybe I put this other vac across this. And I put data equals data. And yeah, other vac. I'm just gonna put vac. Oh, and every time I change stuff here, I have to restart the app to work. And then here I put script. I don't remember really well if that's how it works, but I think it is. So in order to put a variable, use this syntax on Ginger. And have data and vac. Let data equals data. Let vac equals vac. I'm not sure if I have to do anything else here. Sure. And then here I'm gonna console log data. And I'm gonna restart the server. This is some stuff I did before. Yeah, so this doesn't work. I know this part, I'm pretty confident this part is correct. So it must be the script thing. I know it did this before. I think I made it happen that time, so it is possible. Just figuring out the syntax that I have to use here. Might be the percentage. I think I can just try that. See what happens. But I don't think that's the case. Or maybe I can just do... Oh, it's because I'm writing JavaScript in Python. That's probably why. I shouldn't do this. I should just do this. I'm not even sure if I need to make this equal here. Or just declare the thing. Yeah, that's the problem. What if I put this inside of this script? I wonder if it's gonna work. At least it renders the thing, but yeah, back is not defined. I think I can look at these ones because they pass information. Mm. So I declare on JavaScript and then I make it equal inside the thing. doesn't work, it's gonna be a problem. I'm gonna have to figure out how to. Because if this doesn't work, then the other way that I know that it works is if you create a backend. Well, I guess Flask is a backend. But if you make an API call and but then you have to set up this server, right? I think you set up the server, or maybe you can use localhost, the one that it is running wrong right now, and then fetch the data with JavaScript. But then the issue is that you have to put the thing inside of an asynchronous function, and then you have to put everything inside of that function, because otherwise the synchronous code outside of the asynchronous code doesn't have access. Hmm. Wait, vac is here. Oh, I need to export this, maybe. Export data. Export vac. And then this data is not working for some reason. It's the way that this list is done here. Maybe I have to put inside of the function and then export the function. Sometimes this GitHub Copilot can be annoying. I guess I'll put let data here and let vac here. Oh, I know what I'm gonna do. I'm actually gonna put this true here. Sign my expected. I don't know what I'm getting this error now. My idea is pretty much do this. And then because I'm exporting this, I can import on the other file. I don't understand why this is. I'm just gonna try to run and see what happens. Hmm. Oh, so it's the percentage. Sometimes it's on percentage, set data, post data. I guess this is just showing a mistake because it's Jinja. Let me see if there's a Jinja extension here. It's probably gonna help. I should be passing through here. So data and vac. Data vac. Or maybe I have to change the name. It doesn't change anything. Unexpected token export. Oh, and here is not working. Let's see if it, like this works. Probably not, but I want to see how they pass the variables. Oh, I have to use true JSON, I think. That's the thing that I was forgetting. There we go. I think this is gonna work. Even though it's not showing there. And nodes, true JSON, edges, true JSON. Yeah, because it's showing the same mistakes here. And then I pass as an object. But then I have to import there, I think. Imports, get data. Yeah, but then how do I import this? Maybe I don't need to do this. I'm gonna try without doing the function first, because it's easier. So I can't serialize a NumPy array. So I'm gonna have to convert this to a list. That's interesting to know. So whatever I wanna do, I have to do here first. Whatever I wanna do with NumPy, I have to do. I think if I'm gonna do other stuff, machine learning stuff, I'm probably gonna do in another script, then import this data script and run this script here. And whatever transformation I need to get, I'm just gonna put the information on a way that I can parse JSON before I send it to the template. Hmm. I think I vaguely remember seeing something like this where there was there's some difference between NumPy arrays and lists in the sense that with lists, whenever you modify the list, you modify the old one, but with NumPy you don't, or something like that. Is either one you modify and the other one you don't, whenever creating a new one. And I think I vaguely remember also that's for this reason it wasn't so simple to transform. So I think I'm gonna search for this. I'm obviously using NumPy because it's easier to build the the sets that I want with NumPy by using these methods instead of having to type them out on a list. Oh yeah, it's because of the data types instead of NumPy. I think the default is int64 if your computer is 64 and int32 if the computer is 32 bits. The standard for NumPy. But because I'm using 100 step here, it divides in a floating way. Because obviously, if you divide 10 by 100, you're not gonna get integers. And this creates an array with 100 elements from 0 to 10 spaced equally. And I also think that, I'm not 100% sure, but I think JavaScript doesn't have floats, I think. Hmm. Let's see if this works. Hmm. So I can't use strict here. And the problem is not the strict identifier data has already been declared at animations.js. Oh, I have data here. That's the thing. So, yeah. Let me think. Think about a name for this. I'm not gonna use const because I'm probably gonna be modifying the list in the real thing whenever I have the whole thing set up. So maybe I should do DAX data. Like, I'll do it with this notation. The other issue is that this is saying that identifier data has already been declared to animations. So it might be a problem because the variable is being assigned after the script. That's the thing. So maybe I need to put this script at the top there. Because I'm using defer here, and defer makes this in the bottom, but I'm not sure if it is in the bottom, but is above this one. Maybe if I do it like this, then it's gonna load this one first. Maybe I can do this instead of animations as well. There we go. Nice. So it works with floating, but I'm pretty sure JavaScript doesn't have floating numbers. And I think what this method actually does is just get a random number from 0 to 100. And then is multiplying that with the vector here, which is this one. The multiplication is just sums up. Maybe it just creates a random number from 0 to 1. Might be the case. And then because it sums all of them, it gets this number. Because it's a matrix multiplication and not a standard multiplication. So let me think. Yeah, what I'm gonna try is put this stuff here. I'm gonna declare this on the animations file because it's just a lot better if I can do it here. But I'm not sure if it is possible to do it like this because I didn't try yet. Yeah, that's the thing. It only works on the template because the thing is rendering the template. So whatever I want to do with Python has to be inside of the template because that's what the Flask has access to. Maybe I can pass through here as well. There's also something to think about. Yeah, what if I do it inside of this one? But then it's pretty much the same thing. But I think it looks better, actually. Because then I'm not wasting space there. Yeah, it doesn't work. So, at least this way it works. There we go. And now it's 160, so it is what I was thinking, I think. So now let me work on the animation stuff. So I follow a couple of tutorials for animation, but I don't understand really well how the positioning works. I think this is obviously a class, then when you initialize, it creates this constructor, which has an X and Y position for the instance of the class. But the issue, I think this X and Y and these other variables that people use are from, because the global scope of any JavaScript file, I think, is the window. And the window has attributes that you can pick up and use. And I think X and Y are one of these attributes, and that's why it works. And then if you use the arrow keywords, the context is the context outside. If you use this notation, the context is the context in the function. So basically, the arrow changes the context of this keyword in JavaScript. And then here, oh, this is GitHub Copilot that did. But I think, yeah, I don't understand this difference here really well. I think this is the reference for the initial value. Yeah, that's probably how it works. So base X is the initial value of the thing. Then this one is the updated one. And then I'm making equal to the base plus the sign function with this dot entity. So instead of using, yeah, because I have a list there. So I can pass, but it's, yeah. Oh, this is the loop that I'm using to update the thing. So maybe I can put a variable here and then, yeah, dex data. And then here I'm gonna pass dex data I, dex fact I. Dex fact is only one value, so I'm just gonna pass dex fact. And dex data is the array there. The issue is if the array is less than the particles array, but I can control the particles here, the number, which is 100. And then I'm gonna put this, and take this off and put dex data true. I'm just gonna play around and test stuff until I become more familiar with this. And then I start thinking about the actual representation that I wanna get. So it's barely moving now. Yeah, times 1000. Maybe it moves more when it's a lower value. Maybe it's better if I start from the scratch and I think about this stuff that I want here. I think I'm also gonna erase this part. And then on some of the tutorials they did this mouse thing. I don't know exactly. I think it's for when you wanna add events, yeah, mouse move. So let me think. I think what I need to know is the global, the window element. I remember I did this one time, but I forgot how to get, because you can console log here, I think, somewhere. And then you get access to the, oh, it's this one, I think. And so I think these are the properties of the canvas. Let me see. Okay, it's gonna take a long time until it reaches the end of this script. I have to see how to do real-time data flow. Because I was just thinking about if I loop through the rows and get the information from the data, it's gonna be like a synchronous code. So it's gonna do the thing on the data first, on the array first, and then get to the JavaScript part. I want to do something that the animation displays as the list is being filled. So for example, to run simulations based on the block history, that would be cool, I think, as well. But then I will have to find a way to display the thing. Or maybe it works just with the simple animation because I'm gonna have the full list on JavaScript and then I can just do a loop through the list and display the animation with the loop. Which is pretty much the same thing, that's same mechanism here. It doesn't have to be asynchronous from the Python part. You can have everything on the JavaScript and then perform the animation with the list that has the information from the Python thing. So I need to learn position, the lines. I think lines is just simple You just put line through. The difficult part is the mathematics of the thing. That's the most difficult to really think about, because yeah, also ideally I wanna put gravity or something, or physical concepts, to make kind of like the thing not realistic, but to have some feeling of being real, and not arbitrarily choose the positions of things. So I could make something that takes the values of the balances and make it proportional to the gravity, let's say. I think I saw some videos talking about how to have this physics engine effect on the canvas. So I need to connect the dots first. I need to learn how to connect the dots. To make the dots, I think is just this function here. This context is the context that creates the context for the canvas. So get the canvas from the HTML using getElementById. Then you create the 2D context from the canvas element. And then you assign inner height and inner width to the window. And then this event listener is for resizing the page. So the canvas resizes automatically. And I did this on my other project as well, where I got some animation from some other site and I made some changes to make it work. But they used another library. Connecting dots with canvas. Well, I think one thing I can do is change the size. Yeah, that's the thing. Size to size here, and then I'm going to size here in the constructor. And then when I'm passing this, I'm gonna pass the here. I'm gonna make let dot size equals the DAX data I. And that's gonna make the size of each dot be equal to the size of the element on the list. Hopefully. Yeah, there we go. Nice. So there's really small ones and then big ones because it's a random distribution. I think it's pretty easy actually. It just seems a lot harder than it actually is. The hardest part is the physics. And the other stuff of getting the data flow. So pretty much Python and Scala part's gonna be the hardest. And how to make sense of that logic to integrate with physical reality to make the simulation seem like it's happening in real time, and also to allow simulations on the history of the thing. I think that would be cool. I also have this idea of trying to capture fractal patterns based on the simulations or the flow of data, because I think that's how market economy works, or everything in the universe. And that's gonna be extremely hard, I think. And then obviously, once I do everything, then I'm gonna deploy this, I think, as a website and put it on my portfolio. So I'm just thinking about now what is going to be the best way to, when I'm actually have the data, what is going to be the best way to pass the data for the JavaScript. And I think the best way is probably going to be a dictionary instead of a list, because I'm gonna want to have each DAX with a specific key, so I can change the color of the DAX, the color of the dot based on the DAX. I want to pretty much simulate the network X style of graph, but with something that allows me to have way more control over the way that it looks and that it is displayed and it interacts. I think you can probably also make an event listener for clicks on the dots. That also seems like something interesting to do. Which was the original idea I had for modifying the network, the Viz.js library, but it was too hard to. It was taking me too long to change the library. Figure out how to change the library to add the extra functionality that I wanted to add. So maybe it's something I can do here with the canvas. So pretty much I have to figure out a way how to make. Yeah, but then I would have to put buttons on the canvas. Not sure if that works. So as if each particle had an event listener. Maybe to add an event listener to a class. Then I would add a click event listener. That would be really cool as well. I think this is a very interesting idea, because then I can add an event listener for the clicks and then create a function that maybe opens up or displays something about that dot in the in another tab. Also, how to display, yeah, to display information when I hover is probably event listener as well. So I have to see how to add an event listener to a class. To add the event listener to the particle. And what else? So how to each dot. Size, I think I already figured out. It's pretty easy. I'll try the event listener. What else? How to add gravity to each one. How to display flow between dots. Yeah, that's the thing that is gonna be difficult, because I think the only way that I'm gonna be able to display this flow is gonna be after I have the data frame that I'm getting now. And I use that data frame to get the historical balance, historical fluctuations of the addresses of the tokens and the exchanges. Once I have, because I can only do that flow with the fluctuation, I have to create a dictionary with key value pairs to simulate the transactions from addresses. And then I have to do the calculation of the balance, how the balance changes. And then I have to change the size of the node dynamically. So I think all of this is going to be the update function. And this is going to be constructor. Yeah, and if I want to do it from the JavaScript, I would have to get this information already done from the Python. So it would have to be some sort of data that has all the transactions. That's the problem. Because I can't, I think that's the reason why in my mind would be better to make something that flows instead of passing all the information at once through JavaScript. It would be just faster because it's too much data. So instead of using all the transaction histories at once, I have something that generates transactions one by one and updates the animation based on that change. So both the size of nodes and the connection between them changes with the flow. And so I think the main thing that I want to figure out is how to. The thing is that's kind of difficult to think about how to search for this. Live data string is probably the best way to search for this. Connected dots doesn't seem like it's going to be hard. Event listener might be impossible if you can't do that with JavaScript. And the hardest seems to be this one. And this gravity part. It would be really interesting as well if I could pass the formulas for the automated marker makers into the animation somehow in order to determine the weight and the relationship between each DAX. And that's gonna be really complex and difficult. Because then maybe I can create a fractal geometrical model of the relationship between them. So I think I'm gonna search for this. I think the only way to do that is gonna be if I do it the other way, where I'm not passing the variables like this, but I'm doing an API call and setting up a server, because then I can do fetch requests, and then put this thing inside the fetch request. Hmm. Interesting. And that's GitHub Copilot suggesting this. Nice. I'm just gonna copy this stuff here. And then copy this. And here just app. There we go. It still looks like there's some problems. And it's all coming from this file, which is just the Jinja stuff. So while true JSON dumps time, it's a time and the value in an object, and it yields. What a yield does is like a return, but it only displays one value at once, so it saves memory. So it displays this JSON data at every 1 second. The response is probably a JSON response object. It is using this string with context from Flask and calling the function here instead of this one. And passing this response headers cache control no cache. This I assume is just the headers for the API call, which is coming from here, and returns in response. And then here is just rendering the template. And this part is the more difficult to understand. I think this is Jquery and is used a lot, I think, for API stuff from the stuff that I've seen. And the problem is this uses a chart. That's not what I want to do. It's close, but not quite. Hmm. Yeah, maybe I should think about the simple animation stuff before I even think about this. Because this looks like it's gonna be lots more complicating than the other stuff. Ideally, I put the more complicated stuff later, so I have everything set up. Because for the complicated stuff, I wanna make sure I'm taking my time and not trying to rush through it. Because I have to understand, and then if I'm thinking about the simple stuff that I have to do, yeah, it might be worse than leaving everything set up until I get to the parts that is probably harder. I think I'm gonna comment this out. And then I'm gonna comment this because I'm probably gonna use it later. And the animations stopped also for some reason. Oh, I'm passing. No, it's correct. Next data. So I think what I'm gonna do is watch some Canvas animation tutorials and just try to think about how I'm gonna translate that into here. I'm gonna forget about this for now. I'm gonna focus on how to connect the dots. I think there is animation. This guy's channel is really good. I'm subscribed on the other, and I think he has animations that connect dots in the way that I want to connect as well. And I think I already watched, but I'm gonna watch again because I forgot. I think it's this one. So let me think. Oh yeah, how to add an event listener. Oh, first, we need to display data. So I probably ended up having to save this one. I already have so many notepads and stuff with notes on all of the stuff that I was doing. Just quite a lot, to be honest. Yeah, maybe I should save on this thing here. I guess I can do that with React, if I'm not mistaken. But then I think it's overcomplicating the thing. Because then I would have to change the whole thing and install React and npm. And just gonna get too much for. It doesn't need to be complicated on the front end. It's more important what's happening on the back end to make sense of the data. So I can do particle dot add event listener. It probably has to come after this. Then will be click. And then I put a function here. And maybe on click is not the best. Yeah, then I would have to think about, because the issue is, yeah, if I'm doing like this, I'm getting the general class. Not, that's the problem. So it has to be inside of here, I think, that I put this one. Yeah, maybe if I do it like this, inside of here, then I use this, and then here, take the function off. Oh, so I can't do this. Hmm. I can obviously move this to here, but I'm thinking about how I'm gonna use this to connect an action for whenever you click the node. I'm gonna be passing a lot more information from Python to JavaScript through the Jinja template. And I think I'm gonna use this. I probably have to create another function inside of this one. So and then I'm probably gonna put, yeah, I'm gonna make something that retrieves information from the node whenever you click on it. And I guess I can make events. I guess I can put all the event listeners inside of this events thing. And then I put a bunch of functions depending on what I want to do. But I'm not sure if this works. I wonder if I can do it. It's better. Turn 1. Yeah, that's the problem. Or maybe I can do it outside of here. I have to do it before, I guess. Better. Turn 1. So this creates the event listeners, and then the event listeners call functions outside of here. and each function performs an action. If this works, then it might be possible that I will be able to achieve the stuff that I wanted to achieve with the Vue.js library in a much easier way. And if I can do that, then I can go back to the other stuff that I did and add the extra functionality to the other libraries, to the other project. It should be possible to add event listeners as part of classes. Now that I think about it, from what I vaguely remember from the Vue.js network, I think that library has event listeners for classes. And I think the way they did it was with the key events, but I didn't understand that really well, how it works. But I remember they had a bunch of event listeners there. So I think it should be possible. Oh yeah, they use an event emitter or something like that I was investigating, but I couldn't quite understand exactly how it was working. But this is on the development, not on the class. And because I guess event listeners are for DOM elements. That's the thing. And I'm trying to make it for the class. The class should be an object in the DOM. But then it's gonna be the canvas. That's the problem. And because the issue is if I don't make it as part of the class, it just seems like it's gonna be way more complicated because then I'm gonna have to think about how to translate the information of what's happening inside of the animation into the event listener of the canvas. So synchronize the mouse movement and where the event listener is gonna the click but it's gonna happen so that I catch that. It just seems like it's way worse. If I'm able to make an event listener associated with the class instead of the thing, instead of the canvas, then it's just a lot easier. But I guess even on the free code camp stuff on React and Redux, you kind of do that with the state and the props. But it's still, you binding the event, the this in the class, inside of the class constructor, I think. But you're actually making the event on a DOM element still, I think. So it's not the same. Yeah, I guess the only way is gonna be to actually create the abstraction of the mouse movement using the mouse move event listener in the window, and then correlating that with the position of the particles. But with that, there's the obvious problem of if you have particles intersecting, or if they're one on top of each other or something like that, then there can be bugs, because even though the mouse position is in the correct spot, it's catching the other one. Maybe we can do console log high and the stance. Hmm. Yeah. Actually, I can't do like this. I always forget how to declare functions with arrow notation. Seems like it's correct, but I can't do this inside of the class. So maybe if I just do events. Nice. Yeah, it still doesn't work. And it's probably because of the thing that I was talking about, where add event listener only works for DOM elements. And I'm trying to attach it to the particle. Obviously, if I do it like this, it doesn't work because it's attached to the window and not to the. So it's just gonna display. So now when I click, it starts. And because I bind it, if I don't bind, it probably just calls once. It's not reloading. And there we go. So do I have to call this? I guess it's because of the context here. Or maybe if I do it like this instead. I don't think it's gonna work, but yeah. Yeah, so it doesn't work. Yeah, I guess with React it might be possible to attach events. Yeah, but then you're still attaching to the element, to the DOM element. I think I'll be right back and I'm gonna watch the video on this. I remember some of this he talks about event listeners, so it might give me some insight. Be right back.
Hi everyone, welcome to another video in my Canvas animation series where we use HTML Canvas element and pure vanilla JavaScript to create all different kinds of interactive animated backgrounds. The purpose of this tutorial series is to show you how to create animations you can use for your website, show off on your personal portfolio, or just to practice your coding skills. So, in this video, we will build this beautiful animated effect. How about now? Is it better? Don't worry, that was just my first attempt. I have gone through many attempts before achieving this. Creating this one in pure vanilla JavaScript with no libraries was kind of a challenge, but I figured it out and I will share all the techniques with you in this tutorial. In this video, we will build this amazing popular animation you see on the screen right now from Particles.js website, but we will do it with no libraries, just pure vanilla JavaScript. We will build all the functionality from scratch so we have complete control over the code and we will be able to customize it in any way we want. Don't forget to like the video if you like my stuff and want me to make more, subscribe to the channel and click the bell icon to get notified when I release a new video. Just so you know, I listened to your feedback. This video was not my idea. In this episode I was going to show you how to draw stars on canvas. Thanks, Will. Also, I was asked why don't I use ES6 classes instead of constructor functions for this series, and there isn't really any reason not to use classes, so in this video that's what we will do. Although I should say I still believe everyone who is serious about JavaScript should understand constructor functions first, because ES6 classes are just a new way to do the same thing. They are so-called syntactic sugar over function constructors. Underneath, JavaScript still does the same thing. The functionality stays the same under the hood. Classes are just a different syntax, which is easier to work with for people coming to JavaScript from different programming languages. This is the third video in my vanilla JavaScript and HTML Canvas animation series. If you missed the previous episodes, you should. Third, if you notice the and height to the current window, create an event that was introduced with ES6 in 2015, individual particle. We will be calling it over and over from our particle function, from our update function I will create soon. It will be called for every particle, for every frame of our animation, after we calculate the particle's current position and mouse interactions. This method will just draw a regular circle on canvas. We use arc method and give it current x and y coordinates and particle size. Another method we will create on our class is update. It's a custom method, so you can call it whatever you want. In here I will check the current particle's position, check mouse position, move the particle accordingly, and call draw method from here once we know where to draw the particle. As the particles are basically bouncing around the canvas, we will first check if the particle has reached the edge of the screen. If it has, we will reverse its direction x or direction y value to make it animate in the opposite direction. I've already explained this in the previous videos. Now we need to check if the current mouse position overlaps with the current particle position. We call this collision detection. In previous videos, we checked for collision in a square around the mouse, so basically just if the particle was within a certain distance from the mouse on the x and y axis. Now, we want to do the same thing, but we want the area to be a circle. To do that, we take two center points of our circles. One is the center of our particle, the other one is the mouse cursor. We check if the distance between two center points is less than 2 radii added together. Mouse radius is declared in our mouse.radius variable. Particle radius is its this.size value, because that's what we use in Canvas arc method to draw our particles as circles. To calculate that, we use this common formula. dx is the difference between the current mouse position and the particle's position on the x-axis, and dy is the difference between mouse position and particle position on the y-axis. Then we calculate the distance by taking square root from dx times dx plus dy times dy. As I said, now we compare radii of both circles and check if they're bigger than the distance variable. If they're smaller, that means our particles are colliding. So if the distance is smaller than mouse radius plus particle radius, represented here by this.size value, we have a collision. Inside this if statement, we need to do additional checks to see which side the particle is coming from, so we can decide which direction we want to push it. Since we are nesting if statements, these checks are only done for colliding particles. First, we check if mouse x is smaller than this.x, which is particle's current position. If that's true, we know the mouse is currently to the left of our particle, and we will push the particle to the right, yes, which means in plus direction on the x-axis. We also want to check if the particle is far enough from the edge of our canvas to make sure we don't push it over the edge, because it will get stuck there. I chose buffer area of particle size, this.size times 10 around the canvas. If the particle is closer to the edge than 10 times its size, actually its radius, half circle, we will not push it any further. We need to do this for all 4 sides. We check to see if the current mouse coordinates are bigger or smaller than particles' position on the x and y axis, and push particles in the appropriate direction so it appears like they are being pushed away from the center of our mouse radius circle. As we push the particles around, we also check if there is a buffer of particle size times 10 between its position and the edge of the screen for all 4 sides, top, bottom, left, right. After we have checked all of this, we will move the other particles that are currently not colliding with the mouse along their x and y. Afterwards, we will use particle class every particle in our particles array one by one, and for each of them, it will run the inner loop with b variable against every other consecutive particle.
No, I think I'm gonna stop here now. I'm already tired. I think I'll probably continue the physics course off stream now, and yeah, next time I'm gonna be I'm gonna do this thing here, this animation. I'm gonna connect the dots and then I'm gonna see, yeah, hopefully maybe should get to the eigenvector part, and hopefully it talks about, I'm gonna have to redo some parts of the course because it is very complicated and I wasn't paying attention 100% on some of the lessons. But then hopefully it talks about gravity or something like that, and then I can use the library that I built from the course into the animation. So I think next step is connect the dots. Then I'm probably not going to be able to add the event listener, so I'm going to put this in the bottom here along with this one. So connect the dots. Maybe display the flow is going to be easier than add gravity. Yeah, but I think for displaying the flow, I'm going to have to figure out how to display the data dynamically, because the two go hand in hand. So I'm probably gonna put this here. Display flow. Then connect dots. The thing is, I also have to think about how I'm gonna create this class, because I wanna keep track of each dot, so I can change the size later of the balls. And the way that I'm doing here is just adding sequentially based on the list. But then I don't think on the update function, or maybe it is because it calls the same one. So maybe that doesn't matter. Because since I would be changing, yeah, that might matter actually, because I'm gonna be changing the size of the list. I'm gonna be displaying dynamically with the live stream of data. So that might change the thing, the animation. So I think what I'm gonna do next time is just do the simple, let's say, animation on connecting the dots and doing something closer to what this guy is doing, but with the information that I have, that I created here just to test. Once I have this animation, then I think I'm gonna focus the thing that I'm gonna have to focus right after that is gonna be the live stream of data. I think that's the most important part of figuring out, because that's gonna make up the whole animation. And then I'm gonna put the animation on a loop. Yeah, I have to figure out two ways. One to loop through the animation based on the whole history of the data. So once it reaches the final state, it begins again from the beginning. And the other way is just to display it as if it's happening on real time, which eventually that's what I want to do. So it loads up from the beginning, and then once it gets to the end, it stays on that state until it gets new information. So yeah. Next time I'm gonna do the basic stuff. So see you then.